In this next tutorial, we're going to look at creating a flowchart for a little more complicated program. What we're going to do is add up numbers from 1 to n. So when we're trying to create software, and we're given a problem like this, I see too many students who just start to write code, and within an hour or so they're very confused and the code is not too efficient. One of the first things we should do is make sure you can do this by hand. So many people try to write software for some problem and they don't really understand how to do it in their head. So if we were going to add up the numbers from 1 to n, we'll look at how we would do this by hand. So let's suppose from, let's say 1 to 5. So x is 5. Well, if we were doing it by hand, we'd say, okay, we start with 1 and we're going to add the next number, which is 2, and mentally we would keep track of 3 as a result, and we'd say, okay, I got to add 3, so that's going to give me 6, add 4, it's going to give me 10, and add 5, and it's going to give me 15. So we can do it in our head, but what you've got to do is break it down to how would a computer do it. So if we look at variables that we would need in our program to keep track of these things, you see this here is like a running total. So we'll just call this total. 1, 2, 3, 4, 5. This is just some type of counter which is going from 1 to whatever x is. So this is our x. So let's just call this count. So we can do it by hand, and we can see that we likely are going to need 3 variables, maybe an x, a count, and a total. And how are we going to develop an algorithm for it? Well, an algorithm in a flowchart can really be developed together. So they're really the same thing. So now we're going to look at writing a flowchart. And so let's suppose we'll start. And one of the first things we have to do is get x. So we'll use our trapezoid to get from the user the value of x, input x. And we know that we're going to have some variables, x, a variable count, and a variable total. Now count, if you recall from the previous slide, started at 1 and went up to 5. So let's just initialize count right now. So we'll say count equals 1. Now, one thing about flowcharts that is very important when you're doing this is it should be language that is software language independent as much as possible. This can't always be true, but it means that once I write a flowchart, it could be implemented in Java or C or Objective-C, Fortran, Pascal, virtually any type of program. Now, we've got a total, and it's always nice to initialize variables. So total is going to start with a 0 value. You'll notice I just have an O with a line through it to indicate 0. That's a programmer's type of thing. So we should also initialize total. Now, at some time when we end it, we have to look at count and x, because we input x. So we're going to do an example, and let's suppose we're going to input a value of x is 3. So at some time, we've got to say, okay, find out when do I end my program. So we're going to need to say, is count equal to x? Because count was our number that was going from 1 to whatever x was. And if it is, then what we want to do is, okay, we're all done. So we can display our total. And then we would just end our program. Now, if count was not, now we need to do the bulk of the work. That is, how are we going to add the value of count to the total? And a very standard way of doing this is saying that total equals its old value plus count. And then I've got to make sure I increment my count, because remember I was going from 1, 2, 3, so count's got to increment. So using very math-like symbols, we would just say count equals count plus 1. And then we would go back maybe to here. And these all have little arrows on them to indicate the direction of flow. So as a student, you come up with your flowchart, you're very proud that you've done all this, and now you start to write code, right? No, wrong. You've got a first attempt at it. Now comes the discipline part, and what you have to do now is you have to test your flowchart to see if it's going to work. So now we're going to try to debug the flowchart. So we're going to actually step through the flowchart, and you need to do this as well with code. If you don't actually go through code line by line, you won't be able to find your mistakes either. So let's suppose we input the number 3. Count is 1, total is 0. Is count equal to x? Well, count and x, no, they're not the same. So total equals total plus count. So I've got total is 0, count is 1. I'm going to add them up, and total is going to become 1. That's the new value of total. Now, count equals count plus 1, so I'm going to increment my count, and I'm going to come back up here. So I'm pretending I'm the computer. Is count equal to x? No. So I do this again. I add these two numbers together. Total is total, the old value, plus count, and I'm going to get 3. I'm going to increment count again. And I'm going to come up here. Is count equal to x? Yeah, it is. So I'm going to go here, print total. What would I print? I'd actually print 3, and I'd end. Now, would that be the right value? Well, the numbers from 1 to 3 are actually 6, so this is not right. So you need to sort of go through here and see, I did this test here at the beginning. I should have done the test maybe at the end. So what we now need to do is iterate. So we're going to get rid of some of this stuff. Oops. And try to come up with a different solution. So, as I mentioned, the test needs to go at the end. So let's look at doing things like, go back to my old color. Let's go back to the two things, and sometimes you can draw them in one block if you want, but total equals total plus count. And you could even just say increment, because increment just means add 1, increment, oops, count. So that's very valid in a flowchart. And now we want to do our test. Is x equal to count? And all these should be in the form of a yes, no. Yes, we would do our, should be a little longer, but display total. And then we would do our and. And if it wasn't, we would go back up and do this again. So what we've done is we've iterated this. So we start with a count of 1. Our total is 0 as I come down through here. And now here I'm doing total equals total plus count. So as we go through this, I'll do this in a different color, we see that, okay, total is now 1. Is x equal to count? No. Oh, sorry. After we added that, I should have incremented count to 2. Is x equal to count? Just trying to, is x equal to count? No, so I go here, total plus count. I get 3. I'm going to increment count to 3. I'm going to check it, and I got another error. Darn. So this is still not working. Okay, so we're going to look at, it seems to be the increment is the problem. What if I took out the increment here and I put in the increment right there? Okay. Increment count. And then go. So we've got another attempt. And so as we start our program, we're going to say count is 1, total is 0. I'm going to add these two together, and I'm going to get the value 1. Is x equal to count? No. So now I come up, I'm going to increment count to 2. I'm going to add total equals total plus count. So I'm going to get 3 here. I'm going to go down. Is x equal to count? No, it's not. I'm going to increment the count to 3. I'm now going to do total equals total plus count. Total plus count is 6. I do my test now. Is x equal to count? Yes, it is. I display the total. I display a 6 and I end. Now you should probably do this for maybe one more value. And when we input x here, to make this easy, we're saying, or we're constraining x to be greater than 1 integer value, so we don't need to test if x is a negative number or 0 or equal to 1 or anything like that. But this process is how you develop good flowcharts and logic that works. And now only now should you start to actually write software. And you can be confident that you've got a flowchart that works. So many times I see students writing the flowchart at the end of their program, but they've written the program, the logic is very long, lengthy, and inefficient, and their flowcharts could be much, much simpler, and so could their code. So the idea of flowcharts is to give you a process by which you can solve problems, and using flowcharts is one of the steps of the process. So whenever you have any type of problem, you've got to understand it first. So could you do it by hand? If you were the computer, do you understand it well enough to completely do it yourself? So if you don't, then you need to ask some more questions, seek help somewhere to make sure you understand it well. Then you need to develop an algorithm and draw the flowchart. Sometimes it's a little mathematical algorithm you can do by hand, or sometimes the algorithm comes as you draw the flowchart. But this is a step that most people don't do, and that's test. Test the flowchart with numbers to make sure it works, and then you need to iterate, rinse and repeat. So you may need to modify your flowchart, and once you modify it, just don't assume it's going to work again. Test the flowchart until you finally have a flowchart that works for some examples. And you should try to break or try to find some condition that won't work. You don't want to only test easy conditions. If you're doing math, sometimes 0 are magic numbers, or sometimes 1 is a magic number. Try to find numbers that will cause your flowchart not to work, and then try to make sure you adapt your flowchart so it works in all cases. That's when you'll write really good and efficient code. So we're going to give you a little example here, an exercise, and that's to compute n factorial. Factorial is just a mathematical definition. 5 factorial means it's 5 times 4 times 3 times 2 times 1. So you take the number, multiply it by all integers less than that number. 10 factorials, 10 times 9 times 8, etc., all the way down to 1. So your task is to come up with a flowchart that works to compute n factorial. Assume that n is the value 1 or greater. So I'll add that to this. And by doing these, you'll get better at flowcharts. Now, you can use Google and search and find flowcharts for this type of thing, but you really need to develop it yourself because you're trying to build better troubleshooting skills inside your own ability. And eventually you're going to have tougher tasks to do, and developing these processes on these types of problems will make it easier later on.